Okay guys, in this video we are going to solve a problem here on the topic that I just covered in the previous video. I think one thing I forgot to mention about work being positive or negative, and so we got a positive work and we got negative work, and the difference between the two is that when you have an environment and you have a system, something that the work is being done on, or something that is doing work on the environment. So when the system is an object that is being, its energy is being changed, pretty much. And so when the environment is doing the change on the system, the work is positive. And when the system is doing the work on the environment, that work will be negative. I just forgot to mention in the previous video. And eventually, I'm not seeing this level if we're going to see the application of this concept with the signs. But again, as I go through this material, as the problem arises like this, so you should guys be cognizant of this fact. Now, so here's the problem. So a person pushes a 25 kilogram box. Again, if it's not legible here, I'm trying to, I guess, scramble in here and trying to put out some videos with the material using whatever the resources I got at this point. So now I'm going to read the problem. And you can always, this is a recorded video here. You can always go back and always listen again to the problem if you didn't catch a word or can't understand what is written here. So you can always send me guys an email. I'm creating these problems kind of on the fly, so I can go back to the video and actually watch it myself. And if you don't understand something, I will always interpret it, guys. So, okay, so here's the problem. So you got a person pushes a 25 kilogram box across the room at a constant acceleration of 0.95 meters per second square. If the box was moved 8.0 meters, here are the two questions. How much work does the person do, or I should say, did the person do? All right, here's the mistake I just found. Did the person do on the box? And what is the change in the box energy? Okay. Now, how do we solve this problem? So again, I want to organize my, I guess, get the terms here and state what the equal to. So I'm giving the mass in here, 25 kilogram. And please notice that this acceleration here is constant, so there is a net force now applied on the box. And if the box, there was no constant acceleration, that means no work is being done in the box. It's either standing still at equilibrium, in a state of equilibrium, or just moving at the same velocity, let's say sliding. There's a frictionless surface in the room, and it's just sliding right across the room, and there is no net force. It means there's no work done on this particular object. All right, but in this case, we have a constant acceleration. So the mass is 25 kilograms. That's given here. What else is given? Well, I got acceleration here, 0.95 meter per second square. And again, acceleration is in the same direction as the, I guess, as the displacement. So the force here will be positive. The next one is, what else is given here? Oh, I got the distance here, 8.0 meters. Okay, I think that's all I need here. So now I'm going to find out how much the work was done on the box, and also the kinetic energy here. I guess changing the kinetic energy, because initial and final state here. Okay, so what kind of formulas I'm going to use here? Work is equal to F times D. That's one formula. And of course, once we figured out the work that was done on the object, it is nothing else as the change in kinetic energy, because the object was moving. It was in motion. Okay, so here we're going to do the solution, and we know that the force is equal to mass times the acceleration. So I got 25 kilograms here times the acceleration, which is 0.95 meters per second square. And I have to multiply now by the distance here, and the distance is 8.0 meters. Okay, so everywhere here I got two significant figures. two significant figures, two significant figures, two significant figures here. So all you have to do now is plug in. I have to just multiply across. So it's 25 times 0.95 times 8. All right, so I got here work, and I got two significant figures, 190. I was going to say newtons. Of course, it's not newtons, because now look at the units here. Units here, kilogram times meter square divided by the second square. So that's nothing else, it's just the joules. So 190 joules, two significant figures. Now, what is the change in the kinetic energy? Well, we know work is equal to change in kinetic energy. I proved it in the previous video, and it will be just the same number. And that's how you solve problems on work.